Hi guys, and welcome back to Wade's Workshop. Now, those of you that watched the recent video that I put up on making the locking handle for the carriage will have noticed that I was using the variable power feed on the lathe, which I haven't revealed yet. So in this video, we'll go through the making of the variable power feed. Enjoy, guys. While we're on the subject of the locking handle, since I've done the video, I've chemical blued the locking handle just to make it look nice. So yeah, jobs are good now. Really happy. Tried it, giving it a good try out, and it works really well. So my plan A for this project was to use this little 12 volt motor. I've got a 12 volt power supply, and I've got a 12 volt variable speed controller with a reversible switch, which I'm actually using with the new 24 volt. So I gave this a try out. It'll come in for other purposes, no problem. I gave it a try out. Not really powerful enough for what I wanted. It would drive the lead screw, but when you start putting heavy cuts on, it would be stalling out. So I shelved that, and I bought a 24 volt motor. But some of the video actually shows me making the pulley and bits and pieces while I was going down this route, but I just adapted it to plan B, as it were. So yeah, let's get on, and first of all we'll show you the making of the two pulleys. So I've taken the handle back off the end of the lead screw. I got a 60-degree tool, which is correct for the belt I'm going to be using. I've squared it up, squared to the face. I found the center point, which is there. I got a slight throw on the outside, but I'm not too worried about that. And I need to plunge in until my groove is 5 millimeters wide. My grub screw came out the end. So I think what I'll do, I've got my carriage locked at the moment. Set a 0 on it. I think I'll flank either side of it rather than try and do it all in one cut. And just finish it off. So if I go a mil each way, there's my bottom position. So I'll go a mil forward. There. Middle the other side. You just have a quick measure of that. Squealing a bit. Yeah, we're not even 3.5 mil yet. It'll just come out a bit. There's the mill the other way, back to my centre, which is there. Forward, touch that front face. Back to the middle. So there's the pulley with its V-groove. Just try the belt in there. Now I suppose I'll just break the two edges on the top there. Needle file job I think will do for that. But yeah, so far so good. And our width has come out at, well, it's hard for me to show it here, but it is 5 millimeters, which is equivalent to what's on the pulleys on the back of the lathe. Well, there we are. As you can see, the belt fits perfectly in that pulley. So now we need to make a pulley to go on the end of the motor, which is going to be over here. Now I've done a bit of head scratching and come up with a formula where I want about 2/3 the size or the diameter of this one. So I'll measure up the OD of this, and then I'll make a blank 2/3 or 66 odd % of that, and then I'll V-groove it the same, and we should be down here somewhere with our drive motor. Okay, I got a piece of aluminium up. It's too big on diameter. My finished diameter is going to be 39, so I'm just going to rough it down to here. Again, I've got the feeding gauge, and I can just wind the cut on 2 mil at a time I'm taking off, or a mil a side. I got a stop set. And I can just gently wind the carriage forward, out of the way of any flying swap, till I hit my stop, disengage, come back, re-engage, put another cut on, and off to go again. Happy days. So a good demonstration of the lead screw hand wheel in use. Quite controllable. Be better when I got the very power feed on it. Okay. I'll bring you back when I'm down to my 40 mil. That's down to, well, 39.8, which is fine. Finished size is going to be 39 mil. I'm going to swap the jaws out, flick it round the other way, and turn the whole thing down to this max diameter, which is the 39.5, 39.8, whatever that is for the moment. I'll be skimming the 39 to finish size afterwards. Right, so I flicked it round the other way. I'll do exactly the same again. I'll just skim that flange off. And I'm going to face it back until that hole that's in there now. You can see there's a, I just will wind that back. That hole that's in the centre was from the previous job, but I've got enough material to be able to face it back till that hole's gone. It's about 6-8 mil deep, something like that. That's taking 4 mil off there in one cut. Again, I'm winding on the handle because it's only a short distance. I'm just winding it back the other way on the lead screw end handle. I haven't moved the tool, so I should be able to still go into the same reading as I was before, to just match up the two diameters near enough. I think we better have that swap out the way there, don't you? Yes. Come on. A little ring of material on there. There we go. So we got it roughed out. We have a blank 39.8, I think it is, diameter. So I've decided on a shoulder of 20 mil diameter, and it's going to go back. I think I'm going to go for 10 millimeters. So I think my first thing is going to be to face out that existing hole. So I'll just take a series of facing cuts off here until I get rid of that hole, because that's going to have to be drilled and reamed 6 mil at a later stage. So using exactly the same method, I've got a stop set 10 mil back from the face, very close to the jaws. I'm winding on with a hand wheel on the end of the lead screw, and obviously I'm putting a cut on with the cross slide. I'm running at 1000 RPM. I'm just winding into my stop, and I'm taking a mil off at a time, off the diameter, half mil aside. And I'm aiming at a diameter of 20 mil. A bit of swap got trapped in the face of the jaw, that's what that was. might have been between the tool and the face. But yeah, won't take long at all at this rate. And this is very much a roughing procedure at the moment. I think I'll stop there and have a measure where I am. Looks like about 24 at the moment. I'll have a measure where I am and then set my DRO and bring you back when we're done. So a little chamfer on there now. That'll do me. I think what I'm going to do now is hold it on that diameter in a 20mm collet, turn all the outside in the collet to finish sizes, drill it out and ream it 6mm while it's in the collet, all in the same setting, and cut the V groove at the same time. So I've got it up in the collet chuck now. It's right tight back against the collet, which is going to stop me skimming the OD, so I will have to pull it out in the collet. But I'm just going to face it back to the 10mm head thickness. A bit faster than that. The 10mm head thickness, while I've got it in the sort of strongest hold. There's only a mil to come off the OD. I might skim the OD and then push it back in the collet to do the groove. There's 0.2 to come off this face now. We'll put a bit of WD on. I'll take 2.1mm cuts. I'm just putting the cut on with my hand wheel at the back here, which is quite easy to reach a round figure with that. Wind across, slide across. I'll speed proceedings up for the finishing cut. What am I doing? Around 1,000 at the moment. And I think in low range I can actually get, what can I get now? I can get 1650, 1700 in low range. That's probably too fast. 1300 for a finishing pass. There we go. Lovely, 0.1 tickle across that face. Get to the middle, slightly beyond. Line the tool off, again using the lead screw. I'll disengage my feed, and that's it, face to thickness. So I've just pulled it out in the collet, so we got a bit of a gap there. If I just touch the tool off against that face, set a 0, I'm going to come back 0.2. And I'm going to set my stop there. Let me just get the Allen key for the stop. Oh dear me. And I'm going to lock the stop there. Just check where I am. Adjust my stop a little. Okay, that's a safe position. So now when I wind my hand wheel in from the other end, when I engage the feed, I can wind it in, and when I hit the stop, I know I'm not going to crash against the chuck. So I'm just going to skim this final mill off now to make this 39mm diameter. So I've got another 0.22 aside to come off. Just show you how I've got no spray on here. As you can see, winding the hand wheel really is quite controllable on feed. I'll hit the stop, bring it back. It should leave about 0.05 to come off. I mean, it's not critical. The bit that does the work is going to be the V groove, but at least I've got a reference of the right diameter, or what I'm hoping will be the right diameter. And this, oh, with a bit of spray, will probably go all over the camera lens. No, might be a bit of smoke. Here we go. Okay, and that should be my finished size. I'm not going to chamfer it at this stage. I think at this stage I'm going to put the V-groove in, because I've got a good reference for where the middle is. Once I've chamfered it, it's going to struggle to find the centre. Although I could... So I think this time, before I put the V-groove in, I'll just centre drill it and put the centre on it, just to give it a bit of support. So yeah, just give it a smallish centre drill, and I'll put a revolving centre up, and that should stop it vibrating quite so much. So I'm all squared up, I'm on the centre line. Let's put a groove in. I did decide to chamfer it either side. I could still pick up the centre easy enough. Well, that's not chattering half as bad this time. No chatter at all, in fact, and I've gone all the way into that depth. Let's have a quick measure. Oh, dearie me. Gotta lean over the camera there. That's about 3 3/4 mil. A little bit at a time. We're not in any rush. Oh, that centre's made a world of difference. 4.5. I'm just winding my cross compound this way a little bit. It doesn't quite look in the centre, so I'm just moving it over a touch, just correcting on the fly, as it were. I think that's it. Well, that was painless. Absolutely painless. Well, there's the V-groove. I've done it exactly the same as I did the one in the hand wheel, so I see no reason why the belt doesn't fit in there perfectly. So yeah, I think let me just get my little file out. There we are, little needle file with a handle on it. I'm just going to break that edge and that edge there. Lovely. Okay, well, I think that will do me. All I've got to do now is drill it out and remit 6 mil to go on the shaft. I'll double check that shaft, make sure it isn't 5 mil or something. And then I'm going to have to cross drill in the flange, in the 20 mil part, cross drill it and tap it for, I don't know, maybe an M5 grub screw. Oh, I've got some nice stainless steel grub screws now. Oh, that's a nice close-up. Straight in, 5.8 drill. And there's a nice grind on that drill, look at that. I'm going to be kind to it. Give it the old WD squirt. I'm going to need to speed proceedings up a little. So this is a 5.8 drill. I think that chuck's a little loose. I'm going to drill it right through. the part measures up at, well, I haven't put a mic on it. With the calipers it's measuring up at 5.9. I think I better put a mic on it. I'm sure it's specified at 6mm. Oh, I got a bit carried away there. Try not to come across the shot with the bottle, eh? That must be nearly through. Yep, that's right through. What I'm going to do, obviously I haven't got a 5.9 reamer. Rather than measure it, let's go down the route as if I haven't got any ways of measuring it. What I'll do, I'll stop here. So the worst I'm going to be is a tiny bit slack. Now that 5.8, it does not enter. So I'm going to put the 5.9 drill in and see how it gets on. I can see it becoming a 6mm drill, but yeah, we'll see. And as you can imagine, that just ripped through there. It's only taking 0.05 or 2 thou size. Okay. Where did I put it? There it is. Nah, it's going to be the 6mm reamer. Well, nothing ventured, nothing gained. I've got a 6mm reamer that fits in the chuck. I'll stick that up next. So 6mm reamer, I'm running nice and slow. I'm only taking a tiny bit, so going slowly like this, it should be okay. And it's aluminium. I'm doing 300 RPM. So in fact that's about the perfect speed for that in aluminium. Let's just see how deep I've gone. I know this reamer cuts a little bit tight because it's had a long hard life. Pretty sure I've gone all the way through. Let's just check the... You know what, that doesn't quite enter. I'm going to have to run this reamer deeper. I should be able to go all the way through without hitting the drawbar. I'll know if I hit the drawbar, I'll feel it. The very top of the reamer here cuts to size. It's had a lot of use, and the end will cut almost a press spit 6mm dowel hole, you know, that sort of idea. But up on the top end of the reamer it does cut a good size, he says. Let's see how good a size this is. Yeah, I may have to get a better reamer out. That's not quite there. I have got a better reamer. Let's have a dig. So I found a Morse taper reamer on a Morse taper 1 with a 6mm reamer, and I know that one is sharp. So just run it through. Let's just try. We'll settle for that. Chamfer on that leading edge now, I think, needs to be done. And then I can take it out, get it on the drilling machine, drill and tap the shoulder in here for a grub screw, and the grub screw will sit down on the flat on that shaft, and that'll be that pulley done. Okay, so that's the pulley fitted to the shaft on the grub screw. The shaft's down in there about 3 or 4 mil, something like that. I've got it right back against the face with, yeah, I mean, 0.5 millimeter gap so that the back of the pulley isn't rubbing on the casing. There is a bit of backlash, but it won't go any further down that way. So, I need to make up some sort of bracket now to go on the other end. I've got a means by which to try it out. We'll show you that. So my new little universal swivel vise, I can line the two pulleys up. I can move it back and forth on the bench to tension the belt. I haven't talked about the belts I'm going to use. I've ordered 2 new belts for the head of my Warco lathe, of this lathe. Yeah, I haven't got any spares. And I thought, well, if I put 2 new belts on the lathe, that gives me 2 spares that are still usable. And, you know, they're not going to be having as hard a life down here as they would be on the headstock. So I'll put the new ones on the headstock, and I'll have 2 spares, one to drive this and a spare should one go in the future. So yeah, well, in fact, I haven't ordered them yet. I'm going to be trying out the one off the headstock just to try this out. But yeah, so that's the plan. So I need to wire up a control box now using the components I showed earlier, and go for it. Oh look, a control box. That then plugs in the wall socket. I'm probably going to put a plug and socket on here, like an inline plug and socket, but that end's going to be soldered to the motor. That's a 12 volt DC input. Forward, reverse, and the vary speed. All that's in the box is a 5 amp 12 volt 5 amp 240 to 12 volt DC power supply. There is a speed controller which comes with the reverse switch and the variable potentiometer. It comes with all that, which is what I showed you earlier. And obviously I bought the motor, and that connects up to the motor itself. So yeah, we're gonna have to, you know, heat shrink, do all sorts of bits and bobs and what have you. Everything's done in there. I will give you a peek in there, but obviously it's all wired up solid. So the 12 volt motor just wasn't strong enough. I've got the 24 volt motor and gearbox in, and that has an 8mm shaft. So yeah, no worries. Where I drilled and reamed this 6mm, I've got a 7.8 drill, and I'll just open it up and drill and ream it 8mm. Just put it back up in the collet. Probably should have put a bit of spray on there, I suppose. Can I reach the spray bottle? Yes. A bit notchy by there because I'm passing through where the grub screw hole is. There we go. And out the other side. That's a 7.8. I'll grab my 8mm reamer now and ream it out 8mm. Here we are, 8mm reamer. Nice and slow. I'm going to see if this will work. I'm on 260. Yeah, 260 RPM. Seems to be coping with that. I can just feel it slowing down a little. I've just given it a bit more oomph. And there we go, out the back. Okay. Job's not finished until the deburring's done. Up with the chamfering bit. And just a little chamfer on the end of there. Okay. So that's plan B for the pulley. Let's try this on the motor.